Butterscotch Shenanigans.
Hey guys, how's it going? This is Seth Coster from Butterscotch Shenanigans, and this is the start of a YouTube video series where I'm going to show you how to put together a small game, and I'm going to be talking through some of the sort of design philosophies that we use at Butterscotch Shenanigans, and hopefully I can give you a handy set of constraints where if you're a beginner just learning how to code, just learning how to use GameMaker, just learning how to make games, any of those things, that you'll be able to pretty easily pick these concepts up and start making small games of your own. And our biggest piece of advice for anybody who wants to get started is to start with small games, because every medium game is just a lot of small game systems put together, and every large game is the same, right? So if you want to make that big dream game, then it's best to start small, figure out how to execute small game concepts really well, and then work your way up from there. So this series is going to focus on the creation of a sort of roid rage-like game, which is basically you'll be navigating a spaceship through an asteroid field, trying to avoid smashing into bad things. You'll be trying to accumulate good stuff, and we'll probably even throw some bad enemies in there, some bad guys, and give you some sort of maybe fighting or combat capability or something. Going to be kind of playing it by ear a little bit, and hopefully it's informative. So first things first, this is GameMaker Studio 2 that I'm working in. This is the development environment that we use at Butterscotch Shenanigans, and it's our weapon of choice for all 2D game development stuff. So if you're interested in 3D, this may not be necessarily helpful for you, because I would definitely not recommend using this tool for 3D. But this is the best of the best when it comes to 2D. So today we're going to be putting together just some really simple stuff. The first thing we're going to focus on is player movement in the world. And we're going to be working our way toward assembling just the simplest game possible. This is sort of, Flappy Bird tier in terms of how complex it is. And Flappy Bird, I find, is a great example of a simple game because it has absolutely the bare minimum number of components to make a game actually work. And it has nothing more than that, and it just goes to show you that a game that can reach that level of popularity, even with so few moving parts, it has all the parts necessary for a good game. So for this early part of the series, we're going to be focusing on these core components. The first is inputs, which is sending keyboard commands, mouse clicks, all that stuff into the computer, and translating that into some kind of meaningful player action. And an action can be literally anything. It can be just steering. It can be firing a weapon. It can be doing backflips. It could be you can have a lot more complex stuff like building things or destroying things or whatever. But we're going to keep it really simple for this one, and we're just going to stick with movement as our action, so steering left and right. Once you have an action in place, then you need a goal for the player to accomplish. So Flappy Bird is a great example of, your action is to flap in order to stay airborne, and your goal is to just flap as far as you can. But that goal is meaningless without obstacles, because the purpose of a game is to provide a challenge for a player so that they can feel proud of themselves for accomplishing something. And so an action and a goal without obstacles in the way to prevent the player from reaching that goal is a boring, meaningless experience. And so you as the designer, your goal is to provide a set of just sort of ways for the player to fail, but then providing them with the tools they need to overcome those challenges. So these are the minimum components that we're going to be putting into place in order to make this game work. All right, so first things first, we're going to explore the GameMaker Studio 2 development environment so we can sort of get our bearings and figure out what we need to do in order to get a character put into the world and have that character be moving around and able to be controlled by the player. So this is our workspace, and then we have a section here called resources, and the resources are just all the different little pieces that come together to make the game. By default, the resources tree is actually over here on the right side. I've just moved it over here, just out of personal preference, and you can rearrange pretty much anything in the UI here. So if you open up Game Maker Studio and it looks a little bit differently than what I'm using, that's just because I've kind of shuffled things around and tweaked things. So don't panic. All right, so we also have rooms, which there's already something in here. So you notice you can kind of pop these open. There's already a room in here, and there's nothing else in the project. So let's pop open this room. So this room is essentially, you can just think about it sort of like a play space. It's a place in the game where you can put characters and objects and tiles and backgrounds and whatever, and you can create the environment here. So it's just the place in which your game exists. And you can navigate using the middle mouse wheel and kind of zoom in and out, using control, middle mouse wheel, and all that stuff. So I actually don't really use the room editor too often, and we'll talk about that in a moment. But if you're going to be building hand-built levels like in a platform or something like that, then the room editor would be the place where you're going to spend a lot of your time. Okay, so first things first, we need a sprite in order to represent the character in the world. And a sprite is just an image that the game is going to render onto the screen. So if you right-click on the sprites folder and hit create, then you've got this little sprite window here, and by default your sprite is 64 by 64 pixels in size, which is just an arbitrary number. And this is a question that people often ask, is how big should my character be on the screen? And the answer is it depends. It depends on basically how fast the gameplay is and how much of the character the player needs to see. So in a game like Super Meat Boy, the character is only about, I believe, 3% of the vertical space of the screen. But in a game that's a little bit more like a slower puzzle game, there's a game called And Yet It Moves, which is a game where you rotate the camera to solve these puzzles, and it's a pretty slow-paced game. In that game, the character is 20% of the vertical space. So the way to think about it is the faster the gameplay is, the smaller the character should be relative to the size of the screen. But we don't know how big the screen is. We don't know anything yet. So we'll just stick with what we've got, which is this 64 by 64 sprite, and we'll resize things if we need to. And I'm going to just use the Game Maker Sprite Editor here to kind of put together a really simple placeholder image. So I'll hit Edit Image, and this is the Game Maker Studio 2 Sprite Editor, which is actually very robust for pixel art and stuff. We're going to keep it pretty simple though, and I'm going to use the rectangle tool. I'm just going to give my character some kind of like a black box sort of a shape. Maybe give it sort of a pointed front end so that I can see where I'm aiming. So let's do this, and we'll just make the character white for now. Okay, so this is my main character. I'm going to be a spaceship, so it's a pretty good spaceship. And we're going to give it a name. So if I double click on the sprite, then I'm back in the editor. I can also right click it and hit rename, but let's just do this. So I'm going to call it SP underscore player. Actually, let's do ship player. I typically start all of my sprites with the sprite names with SP underscore, and that will become apparent as to why that is helpful a little bit later. But it's just a good thing to do. And another point of note here in the sprite, you'll see this little kind of crosshair floating around. This represents the origin point of the sprite. And you can move it around. You can put it wherever you want. You can also grab this drop down, and you can put that origin in the top center, middle left, whatever. The origin is the point around which the sprite will rotate if you start to rotate it. And that is also the point around which it will scale. So if we put the sprite in the middle center like this, then when we scale it, then the sprite will kind of shrink down and expand from that point. And if let's say we put it in the left like this, then like here's your sprite, and when we scale it up, it's gonna just scale in one direction because there's nothing else on the other side for it to scale, right? So it'll just kind of scale outward from that origin point. So depending on the context in which this sprite is going to be used, you might want a different origin point. So it's kind of, again, it's up to you. And these little zoom tools will show us kind of how big the sprite actually is. So this is the actual size of the sprite. Okay, so we have an image to represent the player, so that's good. And now we need to put the player into the game world. And we're going to do this through the use of objects. So let's right-click the objects folder and hit create. And by default, it's called object 0. We're going to call this O_player. All right, so an object is the bread and butter of what makes your game work. It has a bunch of events in it, and so if we click on events, we can see all the things that will sort of trigger things to happen. So we have things like creation event, destroy event, mouse clicks, key presses. We even have collisions. So if you want to check whether it has banged into another object in your game, then you can have it do stuff. And so all of these events simply trigger code that you write. And so you just have a set of instructions that you pass into the object, and whenever one of these events happens, then it'll run the code that's associated with that event. First we need to give the object a sprite. So if we click on this little no sprite thing, then we can see there's our ship sprite. So we'll click on that. And now the object will visually display the sprite that we made when that object is in the world. And let's go ahead and put that object into the game. So I'm going to open up the rooms folder, pop open room 0, which is the only room that we have, so that's convenient. Okay, and this is where things get a little bit weird in GameMaker 2. Let's see if we can just drag this in. Okay, so you can just drag your object into the room and just put it in there. So that's all well and good. Some of you may run into a problem where you try to drag your object into the room and it doesn't do anything. That's because the room has a thing called layers, and there's a background layer and an instance layer. And if you're trying to drag an object into the backgrounds layer, then you're gonna have a bad time because objects can't go there. All right, so we have our player spaceship out here in the room, and in theory at this point, if we hit the play button up here, this little run button, then we should be able to have the game compile and show us what we have so far. So I'm going to hit that button. Let's hit run. Okay, so this is our game window. So this is what we will see. And here's our spaceship, and this is our room, is this black box, and that's all we have so far. So nothing too exciting yet. So let's try to get this player object to move around on the screen. Okay, so I'm going to double click on _player. I'm going to close down this room, actually. Let's close that. So let's open up O_player. So I'm going to add an event to the player object, and we're going to go to the step event. Click on step. The step event, you can kind of think about it as a frame. So if your game is running at 60 frames per second, then the step event will run 60 times per second. So any instructions that you put in the step event will be executed every single frame. So if you have in your step event, you have the player's X position, and you want to add 1 to it. And every object in GameMaker has some built-in variables like X and Y, which indicate their position in the world. So in the step event, if we tell the player, hey, you're going to add 1 to your X, then every frame that's going to happen. And so this player, and by default the game is at 30 frames per second, and this means that the player is going to move 30 pixels per second. So I'm just going to hit the play button, and we'll see what happens. Okay, so now we have a object that is slowly creeping its way across. Again, there's no inputs, right? We can't actually control anything here, which is less than ideal. So now we can go ahead and add some keyboard commands using if statements so that we can trigger this movement event to happen when we tell it to. And we're going to do this with the keyboard. So one great thing with GameMaker is it happens pretty much as you would expect, where if you, for example, type keyboard, then you'll get all of the you'll get a list of all the keyboard functions that are available. And we want to use keyboard check, which checks for whether a key is held at any given point. There are a number of commands you can put in here, like vk_, which are virtual keys. So those are for some special cases like the F keys, escape, insert, numpad, arrow keys. Or you can say ord D or A or whatever, and that converts that character into a keyboard key. So now, just so this is a little bit easier to see, I'm going to add 5. So all this is saying is, as long as we are holding the D key, then the player will move to the right. And if that's not true, then nothing's going to happen. So let's do this. There. So I'm holding D. You see that? Of course, we can't do anything else, so still this game kind of sucks. So let's try to make this a little bit more interesting. So one option is to bring in WASD, or we could also have the character rotate. The way that Roid Rage works is that the spaceship just constantly moves in one direction, and all you can do is steer left and right. So we're gonna do that, and also, as a sort of a word of caution, by default, GameMaker has your game at 30 frames per second, which is not great. 60 frames per second is sort of the standard for smooth gameplay, and I'm not quite sure why 30 is the default, but it is. So if you go into the options tab down here and click on main, then you can right here set your frames per second for the whole game to be, something a little bit better, like 60. Okay, so let's hit play and let's just see that. So that I should be moving twice as fast now, right? Because I'm adding 5. Yeah, and it's also a lot smoother. Okay, so now I'm gonna add some keys to rotate my character. This is going to be done through the use of a built-in variable called image_angle. So image angle is just the rotation of the image itself, and that's based on the origin that I was talking about earlier. So I'll say, if keyboard check D, then we're going to add to the image angle. So let's just say 10 degrees. This is in degrees. And then I'm going to grab this and I'm going to paste it. And we're going to change this to A. So actually, let's see. A should be adding, D should be subtracting. In GameMaker, the degrees go, this 0 points to the right, and then they go positively counterclockwise. So up is 90, left is 270, left is 180 and down is 270. So this says if we hold D, we're going to subtract 10 degrees per frame, and if we hold A, we're going to add 10 degrees per frame. So let's try this. Okay, not bad, not bad. It's also the case that this is kind of weirdly grainy looking and stuff. So once again, there's a default setting that we need to override. So if we double click on our Windows options, go to graphics, and we should interpolate colors between pixels. And that should get rid of that kind of crappy fuzzy look. So things are a lot smoother looking now. Okay, so we can rotate, but we cannot move. And it's also the case that this right here is a bad programming practice. There's a concept in programming called don't repeat yourself, which is the idea that if you ever want to change something, you should make it really, really easy for yourself by not, copy pasting stuff like this. So we have this number 10, and we should probably just have a turn speed variable that we can use instead of hard coding the number 10 in there. So I'm going to add an event to the player, and it's going to be the create event. The create event happens one time only, and that is upon the creation of an instance of this object. So when this player object gets put into the world, whatever we do in the create event is going to happen one time and one time only. So we can use this to initialize variables. So we can create a variable called turn speed. So we'll say turn speed equals 10. And then in the step event, we can do this. So now if we ever want to change the turn speed, we just change that one variable instead of having to do it in two different places. So this is a much better way to do it. Okay, so the player can now turn at 10 degrees per step, but the player still is not moving. So how do we go about that? For starters, let's do the same thing where we initialize a variable, and we'll call it move speed. And we will call this, for now, we'll just say 3. And this is going to be in pixels per step. All right, so we have a move speed of 3. In the step event, after these keyboard commands, we are going to tell the player to move in the direction that they are facing. As we talked about earlier, the player has an X and a Y position. And you might think that, if you have an angle that the player is going and you want them to move, at a speed in that direction, then you're going to have to get some trigonometry involved, right? Because it's kind of like a hypotenuse, blah, blah, blah situation. Yeah, don't worry about all that. GameMaker has a nice function called lengthdir, where we can just add the length and direction to this X component. So we say lengthdir X. So down here it tells us what arguments we should put in. So our length is going to be move speed, and our dir direction is our image angle. So this basically just does all of the trigonometry for you. So now we are modifying the X and the Y component based on the speed we're moving and the direction we're pointing. So I'll play. Okay, so we're moving. And now when I hit the A and D keys, my spaceship will steer around on the screen. So this is, we're already on our way to having, sort of a little playable game here. And we only have maybe, 11 lines of code if you include white space and everything else. So this is really powerful, and once you get the hang of how these things work, then you can have really, really fast prototypes and concepts up and running in just a matter of minutes. Okay, so we have the player able to move around. It feels like this is turning way too fast and probably moving way too slow. So I'm going to come in here, and I'm going to up the move speed and knock down the turn speed. All right, so this feels pretty good. It's going to be hard to say whether or not this is too fast or too slow or whatever until we actually have things to avoid or have things to pick up. So that should probably be our next move, is just putting something out there in the world for the player to bang into and some good stuff for the player to get. So that'll be our next step. All right, so that's going to do it for this episode. So thank you all for watching, and tune in to the next one, and we'll start digging into collisions and making stuff happen when stuff hits stuff.
Butterscotch, Shenanigans.